Hello and welcome, dear students. Assalamu alaikum to everyone. My name is Gauhar Nabi, your mathematics educator. Today, the topic that I am to discuss with you is one of the most important topic. It is regarding it is about the one most important theorem in mathematics. What this theorem says? This theorem simply says that every perfect square number can be represented as the sum of the odd integers. As in my previous lectures, I already mentioned this thing that mathematics is all about pattern recognition. That at the end we reach certain point of time. We at the end we reach at certain point where we feel that mathematics is more than a subject. More than a subject, what? It is the study of patterns. Everywhere we find patterns. Everywhere, right? So today, the topic that I'm to discuss with you is regarding the patterns. Is one of the patterns that I will show it to you. So let us get started. So the topic is based upon every perfect square number can be expressed as a sum of positive integers, right? So let us suppose that we will take any perfect square. From perfect squares, what do we mean? That whenever we multiply any number to itself, we get the another number. Let us suppose that the 4 is the perfect square of 2, right? Whenever we multiply 2 times, we get 4. 9 is the perfect square of 3. Whenever we multiply 3 2 times, we get 9, right? So, but this 4, if we focus on this 4, right? This 4 can be represented. We can partition, right? We can partition this 4 as in terms of 1 plus 2, 1 plus 3. Whenever we add 1 plus 3, we get 4. So in the same way, that this 9 can be partitioned. This 9 can be partitioned in terms of the odd integers. Whenever we add odd integers, positive odd integers 1, 3 and 5, we get 9. So same case with the 16. So 16 can be represented by whenever we add 1 plus 3 plus 5 plus 7, we get 16, right? So on and so forth up to 25 and so on and so forth. So what from this pattern? These are nothing but these are patterns. What are these? These are patterns. These follow the patterns. What is the pattern? What is the pattern? Pattern is that every perfect square number can be represented as the sum of positive odd integers, right? As the sum of positive odd integers that we can see. So what could be the general term from this? From these patterns, what are the conclusions that we can draw? What are the conclusions? From these patterns, we can conclude that we can write the general form of the general term. The general term will be represented by summation I running from 1 to n. 2i minus 1 equals to n square. Okay. So this is nothing but this what is the physical significance of this general term? The physical significance of this general term says that whenever we add positive odd integers up to n, we get n square. Right? So what will be this n square? N square is nothing but it is the perfect square, right? That we multiply n to itself, we get n square. But now, this is the pattern that we have recognized here, okay? But now, on the other hand, let us suppose that till now, we are acquainted of the fact that if we are to find the perfect square of any number, let us suppose that students are acquainted of this method. Let us suppose that we have 25 and we are told to find the perfect square of this 25. What we will do? We will find its factors. This will become 5 5s are 25 and here we will get 5 ones are 5. So what are the factors of 25? So 25 can be represented by 5 cross 5. So it will become 5 square. So this it means that the perfect square of this 25 is 5. What is the perfect square of this 25? The perfect square of 25 is 5. So this is the method that our students, our educators are acquainted of, right? So what if I tell you that there's another beautiful method that we can find from this theorem, that there's another beautiful method, right, from which we can find the perfect square of a number. What we will do? What we will do? We will do nothing. We will reverse the process. We will reverse the process. So let us see how I will reverse the process to find the perfect square of a number, right? So reverse the process. So how can we reverse the process? Let us suppose that we will take 25 again. We will take this 25. We will take this 25. And we are told to find the perfect square of this 25. We are told to find perfect square of this 25, right? So in step first, what we will do? What we will do? Here we carry on in the forward direction, but here we carry on in the reverse direction. Here we add up on this side. 1 plus 3 equals 4. Here 1 plus 3 plus 5 plus 7 plus 9 equals 25. But on this side, we will reverse the process. Do, undo. Done, undone, right? We will reverse the process on this side. See how we will reverse the process. Let us suppose we will take this 25. Okay? So subtract the 1 from 25. We get 24. This one, right? Now, subtract this 3 from this 24. Subtract this 3 from 24. We will get 21. Now subtract 5. We are reversing the process. We are reversing the process. You get my point? We are reversing the process. So 21 minus 5, it will become 16. So here in fourth step, subtract 7 from this 16, we will get 9. So in fifth step, subtract 9 from 19, we get 0. Now you might ask me the question, sir, why you subtracted 1 in first step, 1, then 3, then 5, then 7, then 9? From where you got these numbers? I got these numbers from this. Right? 1 plus 3 plus 5 plus 7 plus 9 equals 25, which is equal to 5 square. Okay? Here what I did, I simply reverse the process. So now we have to calculate in how many steps we neutralize this 25. This 25 can be neutralized. In how many steps? I'm saying to you, what could be the number of steps? What could be the possible number of steps, total number of steps in which this 25, we eliminate this 25 to 0. We vanish this 25. We eliminated this 25. Right? So how many steps are there? This is step first, step second, step third, step 4, and step 5th. So it will take us 5 steps to eliminate this 25. It would take us 5 steps to vanish this 25. So from this, what we can conclude? From this, we can conclude that if the process ends, if this process takes 5 steps to complete, so it means that 25 is the perfect square of 5. Right? 25 is the perfect square of 5. So this is the conclusion that we can get from this. We can get from this theorem that every perfect square number can be expressed as the sum of positive odd integers. Okay. So here, if there were 6 steps, then the perfect square of 25 could be 6. It would be 6. If 7 steps, if there are 7 steps, in 7 steps we find that the number, if we eliminate the number, vanish the number in 7 steps, then we could believe that the perfect square of that very number is that 7. So this was all about the perfect square numbers and their that I showed here, that I showed it to you in this pattern, that sum of from sum of odd integers. Whenever we add up sum of odd integers, we get perfect square numbers. And on this side, I showed it to you that whenever we undone the process, whenever we reverse the process, right? We get, after reversing the process, okay, we will come to the conclusion in how many steps the process ends. So the number of steps, it will be the perfect square of that real number. I hope you understood the today's topic, right? So see you in the next session. Fi amanallah.